the last set of examples in the note packet are graphing a system of quadratic inequalities. I'm going to go ahead and skip the first one, just so we can look at an example of intercept form with something like this. But really, so if you move down to the second one, when you're graphing a system of quadratic inequalities, again, it's very similar to what we did with linear inequalities. Graph each one separately, and then you're looking for where the two solution regions overlap, and that becomes your solution region for the system. So if you look at this last example, the first quadratic inequality is in intercept form. It is a greater than or equal to problem, so this will be a solid parabola. The first thing we do when we have a problem that is in intercept form is we are first going to identify our x-intercepts. What is our p-value and what is our q-value? And looking at the problem, our p-value is 3 and our q-value is 1. And so those are the 2 points where our parabola will intercept the x-axis. And that means that our line of symmetry will be directly between them, which will be x equals 2. Now somewhere on that line of symmetry is our vertex. And so what we now know is that our vertex has an x-coordinate of 2, and I need to find the y-coordinate. And just like we talked about in class yesterday, to find the y-coordinate when it's in intercept form is you plug your x-coordinate back in and solve for y. And so to calculate our y-coordinate, we would plug in 2 wherever we see an x, which will give us -1 times 1. And so our y-coordinate of our vertex is -1. And again, this is going to be a solid parabola. I will use the test point of 0, 0 again, and what I will find is that 0, 0 is not a solution, and this one I will end up shading in this region. Now the second inequality is in vertex form. Notice this is a less than problem, so this will just be a dotted parabola. We're going to identify our vertex, which is the point HK, since it's in vertex form, which will be 1, 4. And then from there, we will do our rates of change pattern, 1, 3, 5. But in this case, because our A value is a -1, our rates of change will actually be down 1 over 1, down 3 over 1, down 5 over 1, and so on. And again, this is a dotted parabola since it was just less than. And in this case, you can use 0, 0 as your test point again, and what you will find is that 0, 0 is a solution of this inequality, and so the shading will be in here. The area that you want to darken in the most is the area where the shadings overlap, and so that area is the solution of the system.